Hi, Max. It's great to see you. Thanks for joining me today for the Tech Spotlight podcast.
Hi, Theresa. It's great to be here.
So let's start first by having you describe what LinMot USA does.
Yeah, absolutely. So LinMot is focused primarily on direct drive linear servo motors, which you can think of as a conventional servo unrolled. It's great for high cycle, high speed industrial applications. It's a very robust product. And we work closely with Rockwell Automation to ensure that we can integrate seamlessly into your projects.
So today we're talking about LinMot's PR02 linear rotary motors. So describe for me how they're designed and how they operate.
Yeah, so our linear rotary motors combine that linear motor technology that I just described and couple it with an independent rotary servo motor so that you have independent linear and rotary servo motion acting on a single output shaft. This gives you completely programmable position, velocity, acceleration, and also torque and force on that shaft. The PR02 consists of these two motors coupled side by side, which gives you a lower overall vertical clearance than with our PR01 motors. They're also capable of continuous rotation and have optional torque and force sensors available for high precision torque and force control and process data logging. So if you're doing, for example, a capping application and you have a very specific torque target that you'd like to reach, we can use the integrated torque sensor inside the motor housing in order to precisely reach that torque and log that torque for your process data logging capabilities. Inside the PR02 motor housing, which is aluminum, sleek, easy to clean, which can come in very handy in sanitary applications. We can also integrate our MagSpring, which is a passive constant force magnetic counterbalance. So in vertical applications, if you were to lose power, oftentimes the motor will simply drop if you don't add a counterbalance. But if you were to add a spring, you only have the force that offsets the weight of your tooling at a single point in that spring stroke. So what we can do is add a MagSpring, which relies on magnetic interaction between a moving part, which we call a slider, and a stator, in order to provide a constant force throughout the stroke. It's entirely passive and does not require external power, so that in the event of a power loss, we can hold position or even retract up to a safe position. We can also add an optional hollow shaft for example, actuating a pneumatic gripper so that you have access to vacuum or pressurized air at the output shaft. We can reach position repeatabilities of plus or minus 50 microns, which is about 2 thou, and plus or minus 0.1 degrees. And our rotary motors are capable of continuous rotation.
And how about sizes, force, etc.?
Yeah, good question. So the PR02 is available in 3 sizes, ranging from the smallest, which we call the PR02 38. There's a middle size, the PR02 52, and the largest of the 3, the PR02 88. The numbers in the designation refer to the width of the motor. The largest of these, the PR02 88, has strokes of up to 300 millimeters, forces of up to 128 pounds, and torques of up to 7.4 foot-pounds. The smallest, the PR02 38, comes in a compact package measuring 13.5 inches by 1.5 inches, or 38 millimeters, by 3.75 inches. And that smallest motor can reach speeds of up to 7.3 meters per second over its 70 millimeter stroke.
Wow. And earlier you mentioned the aluminum housing. So what are typical applications for the PR02 linear rotary motor?
Sure. So we see the PR02 being used for a wide range of applications in a great variety of industries, but common applications would tend to be capping. So applying caps to especially smaller pharmaceutical vials or parts where that precise torque control and process data logging I mentioned before comes in handy. Oftentimes pharmaceutical companies like to have a log of each part, each cap that they've applied, and they want to have a record of the torque that was applied to each of those vials so that they can see that that torque was within spec for every part in the lot. Again, that smooth aluminum housing I mentioned makes it easy to clean. So for environments where contamination is a concern or the motor has to be cleaned regularly, having that smooth housing makes that much easier. But we also see it used in food. So again, with capping for food, oftentimes torque control or force control can be useful there. And again, that easy to clean nature of the product comes in very handy. But that's not to say that we haven't seen it used in a number of other industries, from automotive, packaging, and beyond.
So speaking of capping applications, what benefits does this have for capping applications?
So using the feedback that you can get from the motor, the position, both the linear and angular position, as well as the torque and force feedback, be that from the current that the motor is providing or feedback from a torque or force sensor, you can get a pretty sophisticated idea of how your process is going. So if the cap has been cross-threaded, if the threads are stripped, if there is no cap that has been fed to the gripper, if the gripper is slipping, all of that is something that you could deduce based on that feedback that you're getting, and you can make adjustments to your process if necessary. So it does give you a lot of control and flexibility that you wouldn't get necessarily with other capping technologies.
So how can people get more information about these motors?
Good question, Theresa. So if you're curious to know more about the PR02, please check out our website, linmot.com, and our e-catalog, shop.linmot.com. And feel free to send us a request with any questions at usasales@linmot.com. We'd be happy to talk to you more.
Great. Well, thank you, Matt. This was interesting to learn about, and I appreciate you being here.
Happy to be here. Thanks for having me, Theresa.
And listeners, check out this episode's description for links to more resources. I'm Theresa Houck with the Journal magazine, and we'll talk again soon.